Welcome to the Driving the World podcast series. I'm your host, Cully Holland. Today we have Jason Hahn, and product engineer from our industrial gearing division, and we'll be discussing our crossover capabilities. Hey, Jason, thanks for coming back on. It's good to see you again.
Hey, Cully. Thanks for having me again. You're not sick of me yet?
Nope, not at all. We'll probably have you back again. Surprise, surprise. But today we're going to be talking about our crossover capabilities with our industrial gearing units. So that's something that we're very proud of, and I think we have an example of one today. So let's go ahead and talk about it.
Yeah, I was just involved in a very successful one recently. Crossovers are always a difficult thing because customers, they get stuck between a rock and a hard spot where they need a better solution than what they've got, or they're dealing with an outdated product that's really expensive to replace or to repair or to get parts for. But on the other hand, removing that piece of equipment can be really difficult because they have to change foundation or move their equipment around, or they're concerned about how it's going to affect their operation. So our job is to make that as seamless and painless as possible for them, so our unit will drop in really easily to where the old gearbox went. In this case, we're dealing with an aerator or clarifier at a wastewater treatment plant. The competitor unit was mounted on 4 studs coming out of the concrete, and so the challenge there was to make sure that we could drop our unit right in there with as little headache as possible for the customer. In this case, we went down there and actually took a nifty piece of 3D measuring equipment where we were able to go scan the existing gear unit to obtain dimensions on what we were needing to match up with. And then our design group here did a really great job of designing a base plate that would drop right into where those 4 studs were sitting out in the concrete. Went great. Low speed shaft lined up great with their the hole in the concrete where the aerator was, connected up well right with their aerator shaft. Some of the other things that we did to make this as simple as possible for the customer and actually improve what they had already was to design a steel welded motor adapter so that they could reuse their old motor. That motor would drop right onto our gearbox, alignment free. The low speed shaft was designed to match the old low speed shaft from the previous gearbox. We also added some features like a dry well, which prevents leaking out of the low speed shaft and allows us to lower the oil level inside the gearbox, which also causes it to run cooler. In addition, our pressure lubrication system inside the gearbox does a great job of delivering oil exactly where it needs to go to all the gears and the bearings. We use stainless steel inside of our gearbox, and they'd been having some issues with the previous one that had brass tips where the brass was just corroding and resulting in poor lubrication inside the gearbox. We also used a shaft-driven mechanical pump as opposed to an electric pump, so their electrical guys had less things to deal with and one less motor to hook up and less moving parts to worry about, since that's all contained internally inside of our gearbox.
Very nice. So pretty much everything I just heard, we took an electronic scan, and that's how we got our dimensions. So it's a literal drop-in replacement. And I'm assuming our gearbox wasn't the exact same size. So with this base plate, we're matching shaft heights and center lines and all of that via this electronic 3D scan.
Exactly, yeah. And because of that transition base, it doesn't matter that our footprint wasn't the same as the other gearbox, because that was all taken into account by the way we mounted our gearbox to that base plate. It's also kind of a special arrangement because these gearboxes take a lot of beating from the application. There's radial and axial loads on the gearbox, and so those things are taken into account in the way that we do our low speed bearing arrangement to make sure that our gearbox is designed to handle those radial and axial loads.
And I mean, that's going to be very important in any aerator or mixer or clarifier application. And you mentioned that the box was running cooler due to some of the additional features you added on. Do you have any idea how much cooler it was running, or do you have a comparison?
Yeah, so the startup went really smoothly. After the gearbox there were no hiccups at all. Once the gearbox was up and running, there was an old competitor gearbox on the same platform right across the way, and so we were able to go and take a temperature measurement of the old gearbox versus ours after ours had been running for a while and it was, up and warm. And our gearbox was running 50 degrees Fahrenheit cooler than the gearbox that was right across the way.
That is a considerable difference. Nothing to just say 1 or 2 degrees, but 50 is quite impressive. So it sounds like if you're working with some of our product engineers and some of our sales force, when we're doing crossovers, our industrial gearing team has a lot of options at their disposal. Is there anything else you'd like to talk about on the crossover side of things, or?
Really just to emphasize that we've got a great group of design engineers and application engineers that support us on the inside that really make these things go smoothly. And, we also have a great group of guys on the outside that are available to be on site. If you need support from the factory, we'll send people down, but we also have our local IG products engineers and also local district sales guys that they can be out there in a pinch and really cover the country well and make sure that we're meeting customer needs and providing a lot of support.
Well, fantastic. I hope our customers do reach out. And Jason, I really appreciate you being on today.
Yeah, thank you very much.